Good afternoon, everybody, and thank you for coming. Today my topic is regarding manufacturing lightweight aggregate and use it to produce lightweight concrete. I'm a PhD student at the University of Birmingham in the UK, and originally I'm a lecturer at King Saud University in Saudi Arabia. First of all, our presentation outline will start from introduction to highlight the problem for our research, followed by the aim of objective for this research, material and method used in this study, result and discussion for the most finding and interesting result, and eventually conclusion of this research. First of all, let me ask you, ladies and gentlemen, do you think is it possible to produce a lightweight aggregate from plastic waste? Any idea? All right, so this is our topic today. We will see the opportunity and explore the potential use of manufacturing this aggregate and use it in concrete. Highlighting this problem, major of plastic waste is disposed in the environment. Only 7% is used as recycled. So the remaining is either disposed in the environment in this way or burned, which expose toxic gases which pollute the environment and resulting in negative impact on the environment, health, social, and cost aspects. So, to solve this problem, there has been a potential use of plastic waste as indirect replacement of coarse aggregate to produce a lightweight concrete. So, a huge research is being conducted on the direct replacement of recycled plastics as replacement totally or partially of coarse or fine aggregate. Whereas, as far as our knowledge, a little research has been conducted on the indirect replacement. So, to answer my question to the possible manufacture of lightweight aggregate, in this study, we're going to produce a lightweight aggregate from plastic waste. Again, can we produce or manufacture lightweight aggregate? Let's see. So, this is our aim. To approach this aim, we're going to achieve this aim by the following objective. First of all, we're going to manufacture the recycled plastic aggregate, then evaluating the properties of this aggregate and compare it with the conventional lightweight aggregate, then produce the lightweight concrete using this aggregate at a full replacement of the conventional lightweight aggregate, and finally investigating the mechanical and durability properties of the produced concrete and compare it with conventional lightweight concrete. So, the material used in this study, first of all, to manufacturing lightweight aggregate, we use dune sand and recycled plastic. So the dune sand works as a filler and recycled plastics works as a polymer or a binder material. So using these two material, filler and binder, using a thermal processing to manufacture lightweight aggregate. Second material, conventional lightweight aggregate, which has been used as a reference coarse aggregate. Fine aggregate, which is a combination of red sand and crushed sand to be used as a fine aggregate, cement and tap water, and two different water cement ratios. Okay, so again, can we manufacture lightweight aggregate? Let's see. Yes, we can manufacture it using a thermal processing, as I said earlier. And this process has been patented in the United States office. So our aggregate is a composite material comprising dune sand as a filler, as I said, and recycled plastic as a binder. So this is our aggregate. As you can see, it's more or less look like the natural or the conventional lightweight aggregate with a significant difference in the physical and mechanical properties. As I said, this process has been published or patented in the United States office under this number in last December 2014. For more information, you can Google it and find more about this, about our aggregate. So, the most interesting part of this presentation, result and discussion. So, the result and discussion, it's going to be two parts. The first part regarding the lightweight aggregate and compare it with the conventional lightweight aggregate. And the second part of the result and discussion is regarding the lightweight concrete and compare it with the conventional lightweight concrete. So, as we can see here, our aggregate is slightly better than the conventional lightweight aggregate regarding the particle size distribution. Regarding the physical properties, our aggregate is 14% lighter than the conventional one, and the absorption is 85% lower than the conventional one. So these two most important properties of the aggregate, which is mainly used for mix design process of the concrete. Also, the microstructure of our aggregate, or the EDX, shows that an ununiform distribution of the filler, which is dune sand encapsulated in the recycled plastic matrix. Also, it shows a good bonding between the polymer and filler. Okay, so now we finish the first part of the presentation, which is manufacturing aggregate and evaluating its properties. Now we're going to use our aggregate as a full replacement of conventional ones at 100 replacement and at 2 different water cement ratios, and we're going to see the effect on the strength and durability properties. Here we go. The most important properties of the strength, which is compressive strength. As we can see here, our concrete is 42% lower than the conventional ones at 28 days, which is expected. And the reason behind that, our aggregate is more lighter than the conventional one. Also, the strength of the recycled plastic aggregate, which is our aggregate, is less than the conventional ones. Comparing concrete at 2 water cement ratios, this figure shows that our concrete is less sensitive to the water cement ratio than the conventional ones. Sorry, this not work perfect. So this is our concrete, and this is the conventional one. At 2 water different cement ratios, shows that our concrete is less sensitive than the conventional one to the water cement ratio. Chloride permeability, which is one of the most important properties for the relating concrete durability properties. As we can see here, using RBA aggregate in concrete produce the chloride ion penetration, which means our aggregate is more resistant to chloride penetration than the conventional concrete by about 15 and 12% with respect to the water cement ratios. The reason behind that, because our aggregate, it has recycled plastic, and all of us knows that plastic is unconductive material. Okay? So, eventually the conclusion. So, the conclusion can be drawn from this study. First of all, solve the waste plastic disposal crisis, of course. Second thing, our aggregate is sustainable material. Why? Because we're trying to save the natural resources of the aggregate, which is mainly unsustainable resources. Also, our aggregate is lower than the conventional aggregate, and it has low water absorption, which is better for a certain application. Of course, using this aggregate will ultimately reduce the dead load of the concrete elements, which means the concrete section is going to be less, which ultimately reduce the total or overall cost of the concrete and the steel needed. Of course, the compressive strength of our aggregate is much lower than the conventional one, but still we can use it in certain application where lower strength is required. For example, for trenching, why? To isolate the excavation for the concrete for maintenance purposes. Also, we can use it for backfill. Last conclusion is regarding the durability of our concrete. As we saw earlier, our concrete is more durable than the conventional concrete. So we can use it in such application where severe chemical attack is present in the soil. So, or we can use it in the coastal areas. Thank you everybody for your listening. And any question, please? Which is not a good sign. Yes? Thank you. Okay. Sorry, can you again? I didn't get your point exactly. Yes. Yeah. Yeah. Yeah, of course. I already mentioned that. Using this aggregate is reducing the overall strength of the concrete, which was 48% approximately. So this is one of the drawbacks of this aggregate. Of course, it has some advantages and it should have some disadvantages, but comparing the advantages and disadvantages of this aggregate and the accumulative for those the advantages and disadvantages, we can say that it's a good sign to produce this aggregate. Why? For environmental and health aspects, also for the cost aspects. Why? Because disposing this plastic in the environment will cost a lot regarding the disposal for transportation, for landfill, taxes. Well, all these accumulative costs will enhance our aggregate compared with the conventional one. The second thing, some countries, they have limited resources of the natural aggregate, as we heard yesterday from one of our colleagues. He said that in some countries there is this deficient resources of the natural aggregate, for example in Japan. So the availability of this aggregate to be manufacturing from a second or byproduct, can we say that, material, it is a good point. Hopefully I address your question. I'm not sure if I get your point or not, but I did my best. Any question?